Hi everyone, welcome to CHEM. Now today's video is on acids and bases. Here we are going to deal with hard, soft acids and bases. Now before starting, already 5 videos are uploaded in channel. You can watch it. I will give the link in the description box as well as the I button present above this video. And if you are new to CHEM, do not forget to subscribe the channel and hit the bell icon for regular updates. Now let us start. So the concept of hard, soft acids and bases was first observed by Pearson. And what was his observation? He observed that certain metal ions like Li+, Na+, K+, like these which have a small size actually can form stable complexes with certain ligands like F-, Cl-, NH2-, ammonia, water, OH-, etc., which are also small in size. He also observed that other metal ions, other types of metal ions like Hg2+, Hg+, copper+, Ag+, etc. can also form stable complexes with another group of ligands which is I-, S2-, Se2-, PPH3SR3, cyanide minus H-CO. He named these ligands and these metal ions as follows, that is, this group was named as class A metals or hard acids, whereas these were named as class A ligands or hard bases, whereas these particular metal ions were named as class B metals or soft acids, and these were named as class B ligands or soft bases. Now we have to understand what was the principle given by Pearson's. So Pearson told that hard acids prefer to bind to hard bases, as we have already seen its preference, whereas soft acids prefer to bind to soft bases, which is also evident from here. So why this is so? Hard-hard interaction is basically stabilized by ionic bonding, whereas soft-soft interaction is stabilized by covalent bond formation. So if you have seen already the video of covalent bonding and ionic bonding, then you can relate to it that smaller ions prefer to be ionic in nature, whereas the larger sized ions can easily polarize and can become covalent in nature, and there is a covalent bond formation. If you have not watched those videos, you can watch it. I will give the link in the description box as well as the I button present above this video. Now we need to know the criteria for this hard acids. So we have already seen that it should be small in size. Since it is small in size, so it should have a high charge. And if there is a transition metal present in it, then they will have a lesser number of d electrons. Criteria for soft acids should be just the opposite of this one. Then the metal ions should be having large in size and low charge. Similarly, they should have excess number of d electrons if it is a transition metal. Next, we will go for the criteria of hard bases. Now in case of hard bases, the donor centers present should be small in size, and as a result of which the negative charge density should be high. Similarly, also due to the smaller size of the donor center, they are more electronegative and less polarizable, and they will be behaving as sigma donor, that is, it will donate electrons from sigma orbital, as well as pi donor, that is, it will donate electrons from pi orbital. Now if we go for criteria for soft bases, then we can say that donor center should be large in size, right? And as a result of which the negative charge density should be low. Similarly, the donor center of the molecule should be itself, the molecule itself or the donor center should contain a vacant orbitals to accept the back electron density from the metal ion. We have already discussed about back electron density in covalent bonding chapter. You can refer to that. Now, if it has a vacant orbital, then it can behave as sigma donor, that is, it will donate electron from sigma orbital, whereas it can accept electron in pi orbital, so known as pi acceptor ligand. So together they are known as pi acidic ligand. Now the last thing which we have to understand is that borderline acids and bases. So the acids which are borderline, neither soft nor hard, are Fe2+, titanium 2+, copper 2+, palladium 2+, nickel 2+, and chromium 2+. Whereas if we consider for borderline bases which are not soft base or hard base, then it is pyridine, NO-, then NO2- and the azide N3-. Clear? So these were the different hard, soft acids and bases. In the next video, we are going to deal with symbiosis, the term symbiosis, which has an application of hard, soft acids and bases, and it will be very important video. So hope this was helpful. This much for today. Thank you for watching. Do not forget to like, share, subscribe and comment.